Today's lesson is about exponents, order of operations, and variable expressions. It contains a lot of variety, but it all should be review, so you should be familiar with this already. It is really important that we know this information in order to be successful in some of the things that are coming up in this class. So what I want you to do is pause the video, take a minute to read through the objectives, the vocabulary, read about exponents, order of operations, and solution. And when you are ready, you can continue watching the video. The first thing we need to talk about is exponents and using exponents. Exponential notation, if you looked on the previous page, you saw s squared and s cubed. Those are two examples of exponential notation. And basically, an exponent tells us to multiply a variable or a number by itself a certain number of times. So in the case of x squared, it's twice, y to the third, it's 3 times, z to the fourth, it's 4 times. And you can see how we refer to those things as we read them. We either say x squared or x to the second power, y cubed or y to the third power, and then once we get past an exponent of 3, we simply just say z to the fourth power or fifth power, sixth power, and so on. So we need to be able to evaluate exponential expressions, and in this case we have some fairly straightforward ones. 3 to the second power, we know that's 3 times 3, or just 9. 5 to the third power. Now sometimes when we have a power that's higher than 2, we don't see them that often, so we can get a little bit confused, but it's basically just 5 times itself 3 times. So it's 5 times 5 times 5. And it's okay to use a calculator to do these calculations if you want to, but I look at it and say, well, 5 times 5 is 25, and 25 times 5 is 125. Okay, similarly with 2 to the fourth power, it can get a little bit confusing if you say, well, it's 2 times 2 times 2 times 2. You kind of lose track of how many 2's you have. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So don't be afraid to use a calculator to do these calculations if you need to. And then the last one involves a fraction. And anytime we take a fraction to a power, we apply that power to both the numerator and the denominator. So we end up with 3 squared over 7 squared. And that ends up being 9 over 49. And they don't have any common factors, so that is as simplified as it gets. Okay, a little helpful hint down at the bottom. It says anything to the first power is equal to itself. 9 to the first power is 9 times itself 1 time, so it's just 9. All right, next thing we need to talk about is order of operations, and this is something that we've dealt with for a long time, and you may have seen it talked about in many different ways, and PEMDAS is probably something that you've seen in the past. I'm going to expand PEMDAS a little bit. If you look in the blue box, you can see that I have broken it out into 4 different categories. P, which stands for parentheses normally, but we like to call them grouping symbols because we have more than parentheses. We have parentheses, brackets, and braces. And it says start inside and work out. So if you see more than one set of parentheses, brackets, or braces in a problem, you always want to start on the inside and work your way out. Exponents, they're pretty self-explanatory. Multiplication and division go together. That's because if we see more than one multiplication or division in a problem, we always go from left to right. And then adding and subtracting go together, and for the same reason. If we see more than one adding or subtracting, we go from left to right. Okay? All right, so in these two examples, the first one, if we follow the order of operations, the first thing we want to do is the exponent. And then the second thing we would do is the division, but we can do them both at the same time and just rewrite the problem. So, and I can do the division first if I want to. In this case, it's not going to affect the rest of the problem. So 6 divided by 3 is 2, and 5 squared is 25. And then when we add those together, we get 27. Okay, all right, so in the next one, this is one where people tend to make mistakes, and what they want to do is they want to multiply the 3 times the 4 and then do the exponent. Well, order of operations says exponents first, so we need to do that exponent first. So it's 3 times 4 squared, or it's 3 times 16, and 3 times 16 is 48. Okay, so be careful when you see those. All right, a couple more examples, and now in this first one, you're going to see something that maybe you're familiar with and maybe you're not, and it kind of looks like a grouping symbol, but it's not. So that symbol you see in the denominator of the first problem is called absolute value, and absolute value is the distance a number is away from 0. And when I say that, what I mean is the distance a number is away from 0 ignores whether it's positive or negative, because the distance it's away from 0 is always positive. So in this case, we have negative 15 inside an absolute value. And what that means is it's positive. Okay, so I can just rewrite this as 2 times 12 plus 3 all over 15, because the absolute value says that negative 15 is positive 15. And now I can apply the order of operations, and I can do parentheses. So I have 2 times 15 over 15. And if we remember from the fractions lesson, we can just cancel that common factor. So I'm going to cancel that common factor, and the answer is 2. Okay, the next one, we've got fractions now, and we have multiplication and subtraction. So I'm going to do the multiplication first, and remember with fractions we multiply across. So we have 3 times 1 is 3, 2 times 2 is 4. So then we have 3/4 minus 1/2. And if you're familiar with measurements at all, if you've used a ruler or tape measure, 3/4 minus 1/2 is really just equal to 1/4, right? But if you can't see that, what you have to do is find a common denominator. So we're going to multiply that second fraction by 2 over 2, so we end up with 3/4 minus 2/4, and 3/4 minus 2/4 is 1/4. Okay, so we end up with what we want. All right, more order of operations. So they're getting more complex, and again we have absolute value in this first problem, and we're going to simplify that absolute value. We can simplify the exponent at the same time if we want to. We can also simplify the denominator at the same time. So I'm going to simplify the inside of the absolute value but not remove the absolute value yet, because I feel like that's something that we need to go slowly with. All right, so we have 3 plus the absolute value of -1 plus 4 all over 3. Okay, so remember absolute value, and it says down in the helpful hint in the bottom, parallel bars on either side of a number, variable, or expression indicate absolute value. Absolute value is always positive, and it gives you an example. 6 minus 9 is -3, while the absolute value of -3 is 3. Okay, so in this case we have -1, so it's going to be 3 plus 1 plus 4 all over 3. And 3 plus 1 plus 4 is 8. So we have 8 over 3. And that is an improper fraction, so we need to write it as a mixed number. Well, 3 goes into 8 2 times with 2 left over, so it's 2 2/3. Okay, next one, we have multiple grouping symbols. So in this case we have parentheses and a bracket. So we want to start at the very inside, so the parentheses on the inside is where we want to start. So we're going to do the 10 minus 1 first. So we have 3 bracket 4 plus 2 times 9 and a bracket. Okay, and we're going to keep going on the inside of that bracket now. So we have 3 bracket 4 plus 18, and then 4 plus 18 is 22, and 3 times 22 is 66. Okay. I tend to say okay a lot. I'm sorry. Let's keep moving. All right, so the last thing we want to talk about today are variable expressions, and this is something that you've probably spent a lot of time with. And what we're going to do with these problems is simply just evaluate the expressions. And in this case, when x is equal to 3 and y is equal to 2. So if we're given values of variables, all we have to do is substitute the number for the variable. Okay, so we're going to say 2 times 3, and you'll notice when I substitute there, I use parentheses to indicate that multiplication. If we don't, sometimes people will not use parentheses and they'll look at that as the number 23, and we don't want to do that because that's completely different. And then y is 2, so we're going to say minus 2. So we have, if we follow the order of operations, we have 6 minus 2, and 6 minus 2 is 4. All right, in the next one, we have some fractions, variables in both the numerator and denominator in the first one. So we have 3 over 2 plus 2 over 2. And a lot of you might be tempted to simplify that second fraction right away and say, oh, it's 3 over 2 plus 1. Well, that's kind of going backwards because we want a common denominator. So we have a common denominator, and so we're just going to add those together. So we have 5 over 2. And it's an improper fraction, and we want to write it as a mixed number. So 2 goes into 5 2 times with 1 left over. So it's 2 1/2. Okay, last thing we're going to do is determine if a number is a solution of an equation. So in this case, we need to determine if 2 is a solution of the following equation. So again, we're going to do the same thing. Now, there's a couple different ways we could approach this. Number one is we could just solve this, but sometimes it's simpler just to substitute the number for the variable and simplify both sides. And when we do that, it's going to create balance on either side of the equal sign. And balance means that it is a solution. And if it's not balanced, then it's not a solution. Okay, so let's go through this. So we have 3 times 2 plus 10 equals 8 times 2. So if we simplify everything here, we have 6 plus 10 equals 16. And we have 16 is equal to 16. All right, so since I have balance on either side of the equal sign, and when I say balance, I mean we have the same number, then I'm going to say yes, 2 is a solution of that equation. Okay, if I did not see balance there, I'd want to say no. Okay, so there it is. That's the lesson for today. What I want you to do now is go to Schoology, download the assignment, import it into Notability, and when you are finished doing the assignment, save it as a PDF and upload it to Schoology.